All right. All right. So let's actually just focus on learning more about LLMs and AI today to kind of just get started in how we can integrate an LLM to our study buddy application.
Okay.
Last we left off is what we're missing here in our game, which is basically our where is it? Our game, right? We had a validate answer here,
Yep.
and we found that it wasn't that great, right? It was kind of poor at determining whether or not we had the right answer, and we could totally cheat.
Mm-hmm.
And so the solution, well, it's not. I mean, it's like an overkill solution, but it's a fun solution to get started with AI. Is using an LLM to help us verify the answer. And so we left off with installing the necessary dependencies to get this working. Fortunately, if we were to go back with our model here, we had that we're just going to basically be interfacing with the LLM through a special server using just pure HTTP. And the Python requests library helps us with that. It just helps us make HTTP requests.
Okay.
Yeah, so if you remember the OSI model, no, this is layer 7. So you trigger that HTTP request down
Mm-hmm.
to the server. Server will then know, what you're trying to ask it and respond back through HTTP. It's as simple as that. There's no like fancy SDK or library you have to include in your program. Just send things through, just talk to the server through HTTP. And we
Okay.
call this REST. Okay?
Rest.
Yeah, REST. And so first things first is that I do want to show you something called Olama. And this is like a very easy way to get started with LLMs. You do need a computer with a lot of memory if you don't have a graphics card, right? If you have an integrated graphics card, like an AMD one, for instance, that would be ideal because that would mean that you might have fast memory.
Mm-hmm.
Memory bandwidth is very important for this type of work. But don't think that you can't run an LLM if you don't have one, right?
So, how much memory do I need, and is it free?
Okay, so yeah, that's a good question, right? So for these models, these are all free. They're like open source, pretty much. Okay,
Cool.
this is not like OpenAI, ChatGPT kind of thing. You're setting up your own OpenAI, ChatGPT type
Mm-hmm.
of thing. Okay, now as far as memory goes, it just depends on how big your model is, right? So, for example, this Llama 3.3 one here
Mm.
is a 43 gigabyte model,
Okay.
and it's what we call 4-bit quantized, right? So that's already like I don't really want to get into that type of detail here, but let's just say that whatever model size here is pretty much reflective of how much memory you might need
Okay.
to run the model. So this computer here, although I have a lot of memory, right? I don't want to be using this one because that's CPU.
Mm-hmm.
I want to use my GPU, okay? And to tell what kind of GPU you have, okay, you can use something called LSPCI.
Mm-hmm.
Okay, you'll get a lot of information about what type of hardware is in your computer. In my case, I have a NVIDIA RTX 2070 here. And this card has 8 gigabytes of VRAM, meaning that I want to actually choose a model that best fits my GPU. I really like Llama because it allows us to run tools and it's very high quality for the amount of parameters you have. So parameters is basically the number of terms that you have in like an equation.
Mm-hmm.
Like think of every single word that you're going to generate with an LLM as like a answer to some sort of math problem, right? The more parameters you have, the more variability you will have to selecting your next word.
Okay.
All right. So for example, if you see like a model has like 1 trillion tokens, meaning that in its vocabulary it can generate about 1 trillion words, and the more specific you are, you can choose something from that pool.
Okay.
Right? If you don't have that many parameters, then you don't have as many tokens to dish out. So you're less creative.
Okay.
And when you're less creative, you have a higher chance of saying the wrong thing. Okay? So you don't want to go too small, but you don't want to go too big either, because what ends up happening is that now you're in the situation where you can't run the LLM. It's too slow because it's falling into RAM here on your CPU.
Okay.
Yeah. So whatever computer you have, it'll run. It's just the question is how fast. Okay, and you'll find that out soon. So what I've done in the past is use Llama 3.1. And I found that this 8 billion parameter one is quite good, but not at this quantization level.
Okay.
I actually run it at a higher level. I usually run personally, and in my videos that I've recorded in the past with everyone else, I actually use the Q4 one, but I think maybe the Q5 one, 5 bits is good. And the one here just indicates like there's another term added at the end, like a bias term, like kind of like an extra like weight to increase that sort of power, right? So that's why this one will be more than this one.
Okay.
So how do we even get started, right? Like, so this is 6 gigs. That should fit into my GPU. Okay. So you're gonna go to olama.com. It's very easy. You're gonna hit download. Okay, and are you on Linux? If you are, just copy this and run the script. So I already have Olama installed, but I think it needs to be updated, so I might as well just run the script again. Okay. So I do that. It's gonna say, okay, you need sudo, and then I'm going to just download Olama. Okay. So I'll wait for that to download. I should have done that while I was talking to you, but let's leave that to download. Okay. So what's with this parameter thing? Okay, so parameters. Why am I doing that? Okay, parameters. You'll see things like 8B, 70B, and 405B. At least for like Llama. Okay, so Llama. And that's a model available from Meta. Okay. A parameter is basically, and I'm gonna butcher this so bad. Okay, just take it as is. Yeah, I'm oversimplifying.
Okay.
So let's just say I have something like this: W1x1 plus W2x2 equals y, for example.
Okay.
This one here, right? This is your term, right? But this one here would be the thing that you're trying to solve. You're trying to solve the weight. You already know these terms.
Okay.
It's backwards, right? You have an answer, but you want to find a best fit.
So we're given x1 and x2?
Yes.
Oh, okay.
Yes. Well, technically, yes. But you want to solve for this to kind of minimize the delta to get this. You want to get close to this answer. Okay.
What does that mean? Like, if it's close?
That means that's the thing you should be. That's the thing you should be selecting, right?
Okay.
So these are the terms you're trying to solve for this. That's like deep learning crap. Okay. But you don't need to know this. You just need to know that this is a parameter right here.
Got it.
Right. So something like that. I'm butchering, I'm oversimplifying, this is how I think about it. Okay. Basically one of those is if you think about, like, let's just take one of these, because the internet's gonna get angry at me because I'm getting all this wrong. Oops. Oopsie. What am I doing? Oh, it's just my file. Okay. So I'll correct myself once I do my review. Right? I learned this a long time ago, and I just don't remember a lot. So okay, well, let me get to downloading the model, and then I'll explain more, because it's very interesting actually. So once you download Olama, see how it just sets everything up?
Yeah.
It'll actually, once it tells you it's done, it'll actually say what GPU it detects here.
Okay.
Right? So then I think you can just do Olama version or something like that. It'll tell you what version you have. Right? And Olama will actually have a bunch of options you can use.
Okay.
But I really only use a few. Olama pull and Olama run. Olama pull is just to pull down model, to download a model, and with a given tag. And Olama run is to run a specific model. Right? So I decided that I'm going to use Llama 3.1, okay, 8 billion parameter, Q6, or Q51, okay, Q51. I want to use this one. And what is instruct? You'll find that there's an instruct and there's a text. What's the difference, right? Okay, so the difference here is that, see, here's a Q8B text, right? The difference here is that what you need to understand is that LLMs are just basically really good text generators. So the main scenario that it's trying to solve originally was to sort of predict the next text that follows some other text.
Okay.
Kind of like an autocomplete, right? So text is the one that is really good with autocomplete. It's a model tuned for autocomplete. Okay?
Yeah.
So instruct, you can kind of think of the other case that you've seen a lot on the internet, is the case where you want to use it like as a chatting scenario back and forth.
Okay.
Like, what does that mean? It means that it's specialized towards reading some messages and then figuring out how to respond to that message so that it keeps things coherent.
Okay.
Okay, so we want to use an instruct model. So how do we do that? Well, I just copy and paste this, right? Okay, you're gonna do that. You're gonna go back to your terminal and you go llama pull, paste that in. So you're gonna pull down this model. Okay, so it's gonna take a while to download. Oops, space. It's oh, you have to specify the model you want. Llama 3.1 like this.
Okay.
Okay, there we go.
Okay, cool.
Yeah, so Llama 3.1, 8B, instruct, whatever. Okay, let's go back to here. It's an interesting discussion because it kind of tells you how to estimate things. So one of these numbers, right, is going to be generally a floating point, and it's going to be 16 bits. Okay, you'll usually see something as F16 or FP16, something like that.
Okay.
Okay, now you might have heard the word tops in
Yeah.
the market,
Like laptop tops.
like 57 tops.
Oh yeah. Yeah.
Not laptop tops, but 57 tops.
Yep.
Right. So this this means Tera, and this means operations, right? And this one's second, something like that. Tera operations second, 57 tops. Okay, so if we do the math here, this is 2 bytes, right?
Yeah.
So 8 bits plus 8 bits is 16 bits, that's 2 bytes. Okay, which would mean that an 8 billion parameter model is going to be what? If we have 8 billion numbers, right, that's 8 billion times how many bytes per one of these numbers? 2 bytes, right? That gives us 16 billion bytes, right? And that gives us an estimate of about 16 gigabytes. So we'll say F16 is 16 GB.
Okay.
Let's cross-check that with Olama. So we did an uncompressed, for example. We call it uncompressed. That's like the raw model. No numbers are. Every parameter is going to be 16 bits. Every one of these like things that you're trying to solve is 16 bits. Right? Again, oversimplifying. You'll see that FP16 right here.
Yeah.
Right? Look at the size.
16 gigabytes.
It's exactly what we estimated.
Yeah.
Okay. So let's say we go back to this discussion here. This is usually corresponding to 8 bits integer. Okay, so that's 1 byte. Right?
Yeah.
So if we actually got a model that was, let's say, Q80, right? That means it's 8 bits quantized. What does that mean? If I had an 8 billion parameter model times 1 byte, what do I get? 8 billion bytes. Okay, so that would mean that Q80 is going to be 8 gigabytes. So far, so good?
Yeah.
Okay, so let's cross-check that. Okay, so Q80, right there, 8.5 gigs.
Uh-huh.
Make sense?
Yeah.
So basically, as you actually start to compress the model more and more, so let's say Q4, right? That's just basically 8 bil times 0.5. That's half a byte, right? 4 bits. That should get us about 4 gigabyte, right? Go back here, just cross check again. Q40, about 4 gigabytes.
Okay.
Right, so 4 gigabytes. Okay, so that will actually tell you, like, based off of the GPU memory you have, the more GPU memory you have, the more accurate your model is for this parameter, right? So let's take a look at this one. This one will be like 140 gig. This will be straight up 70 gig, right? This one will be straight up like 40 something gigabyte-ish, right? And then you can do like Q2, which is half of this, which is like 20 gig, right? This is where like we're getting like, we're starting to get really crappy. You know?
Like crappy results?
Yeah. So it could sometimes be the case where you do an uncompressed 8 billion, you can actually get to better than this level here. It's not always about the parameters, right? It's all about your quantization too.
Okay, that makes sense.
Yeah. But in conjunction with that, it's also about how you set up the conversation through a prompt.
Okay.
Okay, so we'll find that. We'll test that right now. So this is what this means, right? Like TOPS just means like, oh, you could do 57 tera operations per second where each operation is 8 bits. So they're benchmarked against these types right here. We found that actually going from this to Q8 is actually very, very imperceptible. It's not a big deal.
Okay.
But going from there down to like Q6, Q5, you start to lose something. And then Q4 is like when you lose a lot.
Lose a lot of
Fidelity.
fidelity?
Yeah.
Okay.
In your calculations. Precision.
Okay.
Think about it.
Okay.
Because now you only have 4 bits to represent a specific weight. Right? Okay. So, now, let's actually test this. How do we test our model? We can do ollama run, okay, 8b, or llama 3.1, and then the specific model tag, instruct Q5 run.
Okay.
So then it's going to load everything to GPU, okay? So that was pretty fast, okay? So let's actually check to see if we're actually on our CPU, or GPU. So we do a llama PS on another terminal, and do that. You see that we actually accidentally loaded some of our model to our CPU, 6% of it. So this model doesn't quite fit in the GPU, right? But mostly. That's okay. It's for a demo, right?
Yeah.
So I could send a message to test it out. Hello. It's quite fast still.
Yeah.
Yeah. So this is, it's like this is exactly what's, we should be doing. We're just chatting, right? But you can actually force it to send JSON.
Okay.
So going forward, send all your responses in JSON. Do you see what we're doing here?
Yeah.
You can actually force the LLM to only send JSON back to you, and then you can actually parse that JSON.
Okay.
Okay? So here's a trick, okay? So I'm going to type out the prompt, and we're going to try something out here. So I'm gonna load up, I'm gonna create a file here. I'm gonna create a prompt.txt. Okay? And what we're gonna do is we're gonna type up a prompt, which I've already pre-canned. I'm just gonna type it up live to tell the LLM what to do, and I'll explain what's going on once I typed it. But basically what you want to do is, a prompt is basically kind of like a set of rules that you actually send behind the scenes as what we call a system message to the LLM, so that it knows what to expect and what role it has to serve going forward.
Okay.
We call that a system message. Why? It will not respond to it. It will just go, okay, got it. That's it. It will not respond to it, so that it's not. It doesn't think it's a chat. It doesn't think that it's a user asking for anything. It's just the rules.
So like a set of instructions?
Yes, to how to behave, what vocabulary to use, what tone, exactly how to format its responses, a set of rules. If you don't give it a prompt, by default, it's always going to act like a helpful assistant.
Okay.
Right, trying to answer everything. Right, so you have to be clear about what you want to do. In this case, we always want to have some sort of JSON return back to us like this, either true or false.
Okay.
Right, we're telling it to do that. So let's actually talk to the LLM. Like, just create our prompt and it will send that prompt. Okay, so let's do this. You are an agent which specializes in confirming answers, right? Answers from a user based off of a question and answer pair. Okay, we are not coding anything, meaning that we're telling the LLM that we don't want any code at all. Because LLMs are actually like, there's some LLMs out there that are really prone to wanting to generate code, and this is not what we want, right? So yeah. We're not coding anything, and we are not interested in any programming at all. Okay, just to be clear, I just want you to be an agent, right? Which can make, let me put this as word wrap. Edit. How do I do word wrap?
I usually use shift, and then I type wrap,
Wrap.
and then
Wrap always. Wrap text. Oh. Shift, wrap, soft wrap. Wrap text.
I think this one.
Oh, okay.
Yeah.
Okay, great, thanks.
Yeah.
Okay. Which can make judgment, okay, as a question and answer machine. Basically, we want it to be a question and answering machine only. Okay, going forward, you'll be presented messages which represent a question, answer, and an attempt. Okay, so let's actually quote this: a question, answer, and an attempt. Okay. The attempt is an answer by the user. It is your job to interpret them in a specific way. The format of the incoming messages will look something like this. Okay, so basically this is your job now. Your program is going to send content that looks like this: question, answer, attempt. So what does this mean? So basically, you're telling the LLM that the user will always send you content that looks like this as a message, right? And where do these things come from? Well, they come from your game here: question, answer, attempt. You're just going to build a string that looks like this. Okay, and you're going to just send it through HTTP in JSON. Then when the LLM gets this, they'll look at it, it's like, oh, it's in this format, so I should do what I was told to. Right? So it's expecting now going forward that all messages will always be formatted like this, coming in from the user.
Okay.
Which is what your program is. Your program, this study buddy, is actually the user. Okay, we'll demonstrate that later. Okay, so meaning of these. So you're now defining what these tokens all mean, right? So question is the question, and answer. So answer is the real answer to the question. Attempt is what the user thinks the answer of the question will be. Okay? Now, the last thing is, so you've told it how to interpret these things. Okay? So now what we want to do is, I want you to be able to compare the attempt and answer. Okay? Answer to see if they are similar. If the attempt results in the same sentiment, semantic, or contextual, meaning that means if it's like relatively the same, right, in terms of language, then it is the correct answer. In other words, a good attempt from the user at an answer, okay, captures the essence and meaning. Okay, so that's the directions on how to actually compare attempt and the answer for the LLM. Okay, so now I'm going to say respond to all these messages in JSON format like so. So now you're instructing how to actually respond to the message. Like the LLM, how it should always give a response. It should never be like, oh yeah, this means the same thing. No, it's going to be a JSON.
Okay.
Either a true or a false. That's it. So you're teaching the LLM to become a computer. Right? So now we'll say, okay, I always want a JSON that looks something like that.
Okay.
Okay? Now, last thing is possible values, right? Possible result values can only either be true or false. By the way, the LLM understands Markdown. That's the reason why we're using Markdown.
Okay.
It understands Markdown. Right? So now, if you are not confident about the message, always respond with a false response like this. So we're telling the LLM, okay, well, if you're not sure, please be, leaning towards being wrong, rather like not wrong, saying you don't know, or like telling the user they're wrong, because you don't want to trick the user into thinking they know the material.
Yep.
Right? So if it's not confident, just say false. Let the user handle reading the description on their own,
Okay.
kind of thing. Okay, now the very last thing, so that it never ever strays from its format that it's supposed to be responded. Okay. Finally, you must always respond in plain JSON format. No markdown. Just plain JSON format.
Okay.
Okay? Okay, so how do we test this?
Yeah.
Right? This is a good question. So what we want to do is we want to, let's see. We want to test this by going back to here, our LLM. I guess we exited our LLM. No, we're here. Okay, so we go back to our LLM, right? And let's just do this and just run it again just in case, because it has a 4-minute expiration. So I'm going to do a multi-line. Oops. Weird. Bye. There. Okay, so I'm going to do a multi-line. And I'm going to paste in everything here.
Okay.
Close the multi-line. Okay, so it's ready to assist. Right, so I'm going to do this. Multi-line, question, what is the memory technology used in Intel Optane SSDs? Okay, answer would be 3D export. Attempt here is going to be cross point. Okay, so notice how it's technically the same, like it's the right answer, but semantically it's the same answer, but textually it is definitely not the same, right? Your code would have checked cross point in 3D export, and that was it wrong, right? But in this case, it's going to process and say true. Okay. So it's going to literally just only give you back this.
Okay.
And that will come back to you over the wire. Your Python program is going to dissect that and actually tell you whether or not it's true or false. So let's actually demonstrate that even further. So let's actually then try to get it wrong, right? Let's try to get it wrong. So let's do NAND flash. False. It's actually pretty good, right?
Yeah.
Well, why is that good, right? Like you cannot, so this tells us something, right? We can't simply just use an LLM as it is the way we downloaded it and run it. You have to give it a purpose. And
So-
that purpose is with the prompt, right?
So like, is it like tuning it? Like, is prompting the same thing as tuning?
Kind of. You're kind of warming up the LLM to be an agent for you. And this is the whole thing with what Microsoft is saying, like agentic AI. Basically, these models which can fit in your computer that don't have to run up in the cloud. Given if you have a purpose for it, it can serve that purpose very well, right?
Okay.
And the goal is to have actually not one big model to serve everything for you. It's actually to have these multiple small language models that serves a specific purpose because they are prompted to do something very well. And you can add things on top of it to actually make it like really good.
Okay.
So I'm gonna stop it right here for today, and then we'll work on hooking all this up later, maybe tomorrow or something. So
Okay, sounds
yeah.
good. Thanks.
Bye.